just move right along. Our next speaker is Kim Eichhorst. Dr. Eichhorst is co-director of the Bosque Ecosystem Monitoring Program, that's BEMP, and research associate professor at UNM. She started research on the Bosque in 1995, working with Cliff Crawford, who I think many of you have had the opportunity to meet and was truly a significant contributor to our understanding of the Bosque. She's been with BEMP since 1999, focusing on bosque ecology and the impacts of historic and anthropogenic drivers. She says, good quote here, except I can't read it. We are here as a society because of the river. Without the river, we lose the bosque, wetlands, and wildlife corridor that is essential to so many species. So with that, I'll introduce Kim Eichhorst.
So I thought I was really going to be delivering bad news, but I forgot that I was following 2 climate change talks. So I'm feeling that this is going to be a lot more positive now. So BEMP was started in 1996 with funding from the National Science Foundation. And its 2 main goals are scientific long-term monitoring of the bosque and environmental education outreach. And we do this by using K through 12 students and their teachers, along with university seniors and graduates, in the hands-on monitoring of the bosque. And because we have BEMP staff and university interns with the students, the data they collect are quality controlled and valid, and they're actually used by various federal, state, and local agencies. And the students are out learning science by doing science, and they are gaining a sense of stewardship for their local landscape. And I can't stress this enough. One of the things that I do when I go out with a class, whether it's my university class or a group of 2nd graders, is I take a little survey, ask how many of you have ever been to the Bosque? And I expect you guys would be close to 100%, if not absolutely 100%. Normally what I see is about 50%, that half these kids have never been to the Bosque. I have 2 students now that have grown up and lived in Albuquerque their entire lives. They're in seniors at UNM, and they've both said that this was the first time they've ever been to the Bosque was in my class. So how can you appreciate or understand or want to protect something, or even understand why it's important to protect something if you've never been there? So we are getting kids out on the landscape and promoting that sense of stewardship. So we now have over 17 years of data. We have 11 core data sets, and we get about 5,000 students every year involved in the program. And these students come from 45 different schools and from 6 different counties. And the students are out every month, 1,000 to 2,000 kids every month returning to their site, and they are looking at depth to groundwater and the water level in the nearby ditch or drain, and then all this is correlated with the USGS river flow data. They collect precipitation data and litter fall, and this is kind of a measure of primary production, the leaves that are coming down, reproductive parts and wood. And then we have 7 other data sets that are collected by BEMP staff and scientists. And these data sets are requested and used by different scientists and federal and state agencies, local agencies, including the U.S. Army Corps of Engineers, the Middle Rio Grande Conservancy District, City of Albuquerque Open Space. We started with 3 sites in 1997. We added 2 already this year, and so we're up to 29 sites, covering about 350 miles of the Rio Grande. We have 3 Pueblo sites north of Albuquerque and 15 sites in Albuquerque. And then our sites range from Bosque Farms, Los Lunas, a cluster of them through Belen, down to Sevieta, which is one of our partners. We partner with Sevieta Long-Term Ecological Research, and Limitar. And then we have a site down in Las Cruces at Mesilla Bosque Valley State Park. So I know we had a little bit of this a month ago, but just a real quick overview. The historic driver for the system was the overbank flooding of the river. And the river would meander across the floodplain, and it would move. Its channel was not stationary. And when it shifted around and overbanked We got wetland areas, you can see off to the right. We had backwater areas. You have grassy meadows and wetlands and these young patches of cottonwood and willow forest that might be wiped out the next year with that flood. And then you can see these pockets of old remnant stands. So as the river would move, it would leave behind the cottonwood forest. So we get a maturing forest that would eventually start to senesce. And most of what we see today as we're walking in the Bosque are those senescing forests. The cottonwoods are over 70 years old. So what we see today is the result of a lot of the anthropogenic impacts on the system. We have a very confined river and therefore a very confined bosque. It's trapped between the river and the levees. It's straightened. When we look at the river below Cochiti, it's very degraded. It's eating away, and the sites are very perched, so it's very difficult. These sites are very unlikely to experience overbank flooding. Another impact is we've brought in a lot of invasive species that are exotic. They don't come from here. And we've deliberately planted salt cedar and Russian olive to control erosion of the banks. And then we brought in other exotic species to control those exotic species. And we've introduced fire to this system. And in the last 25 years, all of the Bosque fires have been started by people. Whether deliberately or accidentally, this is a direct result of people in the landscape. We've also introduced clearing of exotic trees and wood chipping. And fragmentation. All the bridges and dams that cross the river in the Bosque have a direct impact on the Bosque. And so BEMP monitors the impacts of not only flooding and drought, but also fire and clearing and landscape alteration. And some of the things that we're finding, if you have a clearing event, or actually a fire, and you do not follow up with flooding, you get an increase in exotic plants in the understory. And so if you're looking at this graph, all I want you to really see is from the shaded area to the clear area is that increase in purple, and that's the increase in exotic plants at these sites that did not have flooding. On the other hand, if we have flooding at a site, whether it's following fire or clearing or just happens to be an overbank site, then we have native plants dominating. We also had the opportunity to have participated in a project where we had landscape alteration, a bank lowering. So after a fire in 2008, this area was cleared, and then 2 to 4 feet of earth were removed so the river could then overbank flood, and we were left with a high diverse native plant population. And then because salt cedar actually has very similar requirements for germination as cottonwood, and there was quite a nice seed source for salt cedar at this site, we actually had about over 10 times as many salt cedar seedlings that came up as cottonwoods. And you can see that here, and initially it was rather disheartening, but in greenhouse experiments, once the cottonwoods have germinated, they actually outcompete salt cedar. And the same was true for the field. So we then had, within the first year, after the first full year, cottonwoods dominated. And you can see that here, after the fire, only salt cedar came back. We had no cottonwoods coming back at this site. And then following the bank lowering and the flooding, you can see the first year after flooding that cottonwoods dominated this site. But the mature trees need that connection to the groundwater as well. And once the water table drops below 3 meters or 3.5 meters, you start to get cavitation. The air gets pulled into the roots, and you get limbs dying and cottonwoods dying. And so when we look at one of our sites, this is on the west side of the river in Albuquerque, below the drinking water project diversion dam. And first off, if you notice the blue line, this is our depth to groundwater. So if you're walking along the top axis there, that's how far down you'd have to go to hit water. And it tracks really nicely with the purple line, which is river flow. And the first little 2 red arrows, I'm used to walking and waving, so the first 2 arrows are during construction of the dam. And in order to build the dam, they had to dewater the river. You had to push the water flows off to the east bank so you could build in the riverbed and put in the dam. So that had a direct impact on the water table. And then the river flows came up in 2005. They had to stop construction, and when it started again the water table dropped. And then what you can see as we go through time is that as the water was diverted for use, and then more importantly, as we come down to these next set of red arrows, Along the west bank, after they started diverting water, their sandbars started to build up along that west bank, and they are now very heavily vegetated. They are new bosques, if you will, very young, native-dominated bosques, but that has increased the distance between this site and the river, and it has had a very dramatic effect on groundwater levels, including those little brown dots from 2012 where some of our wells went dry. And what this means for the cottonwoods is when the water table drops, you get limb mortality in the top picture and tree mortality, and that leads directly to increased fuel loads as those limbs drop. And anything over 12 tons per acre represents a catastrophic fire hazard. And you can see a lot of our sites have had some sort of clearing event, but a lot of our sites still are above that catastrophic fuel load. So what does this mean when the river starts to dry? Well, here is a change in groundwater levels. And so we're looking at the change from 2008 to 2013, and these are our most recent drought years. And if there was no change, if the water level in the ground stayed the same, there would be no bar. So the little blue bar, anything above that zero line, is an increase. We've had one site that had an increase in groundwater. And then all these lines that are in the negative, and the red lines, this is a decrease in groundwater level at our site, everywhere from 5 centimeters to 60 centimeters. And what is the vegetation response and arthropod response to drought? These three critters here are all really nice indicator species. Roly-polies are actually exotic, but we find significantly more of them in our flood sites, and they have a significant decrease in population when we have a drought year. And then similar story with the ground beetles, the little carabids. They also respond very negatively to the drought years. But when we look at everything across the board for arthropods, again, anything below that zero line means a decrease from 2008 to 2012. The blue in this case is precipitation. So we've seen a drop in rainfall in the last 4 years. And the green line, that's the understory vegetation. So most of our sites have had a decrease in vegetation. And then the arthropods, if you're not looking specifically at the carabids, they're doing their own thing. So when we're looking at species diversity, again, the purple line, that's arthropods, and they're all over. And when we're looking at plants, the little blue asterisks, those are our flood sites, and they tend to be, not only have a higher diversity, but it's a higher native diversity. And then the sites off to the right, these are our old cottonwood forests. They have the lowest diversity. And actually some of our sites in here are open grassland areas that have high exotic species diversity. But these aren't the only critters that are important and depend on this little stretch of river, this corridor that we have. So what does it mean when we have prolonged drought and the climate change predictions? Decreased groundwater means increased mortality, not only for cottonwoods, but any of the phreatophytes, the shrubs that are dependent on the groundwater. Means greater fire hazard, and it also means less opportunity to restore river function and allow that overbank flooding. So how do we keep this from turning into this, or burning and turning into this? This is my plug. We need to bring back the mosaic and not focus solely on cottonwoods. We need to have the increased ecosystem resilience. If we have those cushion zones, those healthy zones where we have the ability for shrinkage, if you will, in the dry years and for the wetland areas to expand in wet years, then we can take this and not just focus on this, but have more wetlands, more wet meadows. In the areas where we know we can't support a bosque or a wetland, then we need to look at upland species, have more grassy meadows, more native shrub areas, and use those outfalls from wastewater treatment plants, willow swales, and where possible, to restore that river function, allow the river to flood, and have our native cottonwoods and willows dominate. So that's it.